In this video, we'll talk about local type inference, also known as implicitly typed local variables. This introduces an easy way to create a variable without having to know the type ahead of time, but allowing the initializer to dictate the data type. When we work with LINQ, many times it may not be very clear what a given LINQ query is returning, and so local type inference allows us to say we really don't care what it is, just let VB figure it out. Now, Microsoft suggests that you use this technique when working with LINQ to make development easier. Some authors I've read insist that you should use it as a temporary measure until you can figure out the exact return type. One technique would be to set a breakpoint and use the debugging tools to figure out the actual type. Whichever you decide is up to you, but the one thing to keep in mind is that this technique only works for the local scope. You can't return or reference a variable created with this technique outside of the scope of a local method. So let's look through a few examples and see how all this works. Okay, so as you can see, I have a blank project called Local Type Inference VB, and the only thing I've really done is add this console write line, press enter key to continue with the read line, just so we can stop the execution of the application. I'm going to paste in our first example here, and you can see that it is dim first equal to 7. So what is the data type here? Well, before Visual Basic 9, you might think that this was an object set to the value 7. However, if we were to run this second line of code, we're going to look at what the type is and display that for our first variable. And you can see that the variable is of type system.in32. It's not of type system.object. Let's go ahead and comment these out. Now, just to prove that that first variable is not type object, I want to try this again, but this time I want to reassign our inferred local variable type to a string type, which should be totally doable if our variable were of type object. So this time we have dim second equals 7, and we're going to then try to set second equal to hello world. Again, if this is really an object, then this line of code should work just fine. So let's run our application. And you can see that we get an invalid cast exception. Conversion from string hello world to type integer is not valid. So what Visual Basic is really doing is saying, I don't know what this is, but now I look at what you've entered here in the initializer, and I can deduce from that that this should be an integer of type 32. So this line of code is exactly the same as doing this. Whoops. There we go. Okay, what might be a little bit confusing here in this whole thing is if we were to do something like this. Let's go ahead and comment that out. If we were to create second as object equal to 7 and then try to get the type, let's see what Visual Basic returns to us. Second variable is of type system.in32. So you might be confused and say, well, did we implicitly type second to ignore object and set it equal to 7? Set it equal to an integer because of our initializer here? Internally, the number 7 is boxed up into an object, and so it is represented as an integer. However, in our first example, the first variable, there's no boxing. It's created as a system.in32. So it's really a matter of how it's handled internally. All right, let's comment these out. Okay, and the point in this little snippet, this little example, is that once we have created an inferred variable type, it can then be used like any other type from that point on. So you'll see here that we have created dim fourth equal hello world. Implicitly, that would mean that fourth would be of type string. Then we're going to dim fifth and we're going to set it equal to fourth. So what would we expect fifth to be? Well, we would expect it to be the same type as fourth because it's deriving its type from the initializer. So let's run this application and see if both of the types are indeed string, and as you can see, they are. Okay, so now let's take a moment and talk about what you can't do, or those things that are not interpreted by Visual Basic as local type inference. First of all, if you were to do this, it will not consider this to be an initialized variable, and therefore it will not apply the rules of local type inference. So this would not apply. This becomes an object. Variable sixth is of type object. And you can't do this either. So in the previous video, we just saw how to declare nullable types. That will not work. If we try to run this application, let's paste in one more line of code here. So we're going to try and get the type of seventh. If we were to try to run this application, we'll get an exception here. Null reference exception was unhandled. Object reference not set to an instance of an object. Okay, so you cannot infer the type if the type is unknown. Since nothing is an unknown value, it can't infer the type, and so this won't work either. And although I'm not going to demonstrate it, it can only be used in the context of a local method. You can't use it when creating types, classes of your own. You can't use it when declaring private member variables within your classes. It doesn't work in any of those situations. So you might find yourself wondering, well, when is this helpful? It doesn't make a lot of sense why they would add that. And this is where LINQ comes into the picture. And so we have a little LINQ example here, and I realize that we haven't covered this yet, but hopefully it'll make some sense if I just explain through it a little bit. Okay, so what we have here is a string, array of strings rather, called states, and we have a number of states that are added in the array initialization. Okay, Texas, Illinois, New York, and so on. Okay, so as you can see here, we have a local type inference set to a LINQ query expression. We don't know what type is going to be returned from this query expression, so we don't need to worry about this. We're going to let Visual Basic sort that out. Now, I happen to know that since we're working with an array of strings, this is probably going to come out to be iStates will be an array of strings as well. However, when we get into some more complicated situations, when we're creating, for example, anonymous types through the projection here in the select statement, as we'll get into much later in this series of videos, the type is not always clear. In fact, if it's an anonymous type, what are you going to set this equal to? So that's really the value of this new feature of local type inference within Visual Basic. So just for completeness, I'll go ahead and run this, and you can see we get states that start with the letter I, and at no point do we have to define what iStates actually is, neither here nor here. We don't know, and we don't really care what iStates is. Visual Basic knows, and is able to work with that and iterate through it. Okay, so local type inference in Visual Basic 9 is just a way for you to, a convenience when working with LINQ specifically. You can also use it in other parts of your application, but specifically geared towards LINQ, it allows you to easily write LINQ statements and not have to be so concerned about what's being returned. It just allows you some convenience, and it can only be used within the local scope of a given method. And as we noted, that there might be some confusion in regards to its relationship to declaring something as an object. But if you take a little bit of precaution, think a little bit about what you're actually doing, it shouldn't be much of a problem for you. Okay, thank you.
You just finished watching another great instructional video from LearnVisualStudio.net, your easiest way to learn ASP.NET, C#, Visual Basic, and more.